That'll wake everybody up, right?
I work for NASA at the Kennedy Space Center. Assemble.
Okay, I don't know that I need a microphone. Can everyone hear me? Okay. All right. Awesome.
Okay.
I don't usually need a mic. You guys are like my class. Everyone sits further away from the front and, had to make sure everyone's paying attention. So I'm Anita Vila-Parrish, and I'm on the faculty at NC State, and I'm an industrial engineer, and that's the department I'm in. But just to give you a little bit of background about me, and then I'm going to talk a little bit about industrial engineering. But first, how many of you have heard of industrial and systems engineering? That's more than I usually get when I talk to our freshmen, because a lot of students don't really know much about industrial engineering until their first day at NC State, but then they're all sucked in. So that's going to be my job today, is to convince you that there's an inner industrial engineer hiding inside of all of us. So it's up to you whether this is a career path that you want to undertake. But I think hopefully you'll see that this actually connects to a lot of different types of engineering disciplines, even the computer science talked before us, because we do a lot with data. And harnessing that data obviously has a lot to do with the infrastructure, the IT, and all of those sorts of things. So even though all the engineering disciplines have these different emphasis areas, we really do all need to work together and know a little bit about each of those areas, enough to be dangerous, when we work with our counterparts in every discipline. So when I did my undergraduate degree here at NC State in industrial engineering, and I took a non-conventional route in terms of the faculty that are usually in academia, which is that I worked in industry before I went back to graduate school. So I had the opportunity to work at Dell Computers in a product development organization. So we were developing all the laptops, and specifically the corporate side, so the ones that were being purchased not by you all, but by companies. And I had a really great opportunity very early off the bat to start traveling to China and Malaysia, where we actually built the laptops that people would buy. In the United States, they were all made in Malaysia, and to Ireland as well. So I lived in Austin, Texas during that time, and it was just a great career path in terms of getting to work with lots of different types of engineers, getting to work with people in marketing and service. And I think that's really a strength of industrial engineering, is we don't work in a silo. We cannot work in a silo, because as you'll see, our job is to improve processes, and processes exist in every area of a company. And we're going to need to be able to understand all those areas so that we can impact them and improve them. Otherwise, we're not going to be effective. So I think it really gives you a lot of opportunity to figure out what you like, what you don't like, because you'll have exposure to the entire company, not just to your organizational unit. So I want to just throw out the challenge. Are you an ISE? As we talk about it, you can be thinking through that question. So something that we think is pretty unique to industrial engineering is that we take more of this systems approach. I'll give you examples as we go through just a couple of the big areas where industrial engineers work. But essentially, in order going back to that idea of improving processes and systems, we can't just understand a small piece of what defines that process or system if you truly want to be able to improve it. Let's think about a grocery store, and you're going through the checkout line process. And you want to figure out how to make that process go more quickly so you have less wait time. If I only looked at the size of the cart, the shopping cart, maybe as part of that process, maybe the carts are too small and that's making all the groceries pile up, which then makes them take longer to take out and scan. That's only one part of the process, and I might say, I'm going to design a bigger cart. That's going to solve our problem. But if I didn't look at things like how many cashiers we have staffing at a particular time of the day, I'm obviously going to miss an opportunity to evaluate the entire system. And so we really want to make sure we're taking this very holistic approach, which again requires us to have to work with a lot of different people, look broadly, communicate, and bring in our mathematical skills, though, ultimately to come up with what the solutions might be. So I'm going to talk about just 4 areas that industrial engineers commonly work in. So as you can see, we work a lot in supply chain and logistics, so I'll give you some examples of what does that actually mean. Manufacturing processes, ergonomics, and areas in analytics. So the first one here in supply chain, how many of you all order things online? We all do, right? But do you ever wonder how they got to you? it's just like magic. You open your door and there's an Amazon package out there just waiting for you, right? And now, has anyone used Amazon Now? Where you can get something in 2 hours? That's amazing, right? That's a logistics optimization problem right there. So companies like Amazon, where they do have products that they've developed, but think about just their core business of getting you the thing you ordered. They're having to make a lot of decisions in order to do that in the most cost-effective way. They don't want to store everything, let's say, in California for the entire United States. Why wouldn't they want to do that? I told you all this is like my class, so now I throw out the questions to you. Why wouldn't Amazon want to build a giant distribution center in California for their U.S. market? Takes too long to ship, especially in a cost-efficient way, right? They could fly stuff. That's what we did in Dell when we were flying products from Malaysia to the U.S. because no one wants to wait a month for their laptop that they just ordered, right? You want that now. So same with Amazon. If I order this toaster, it's probably because I want it fairly quickly, and I don't want to wait a week to receive that product. So Amazon and the industrial engineers there, and at UPS and other similar logistics providers, they're having to determine where do they store the product. That's a key piece. And then also, how much of the product to store. And that's a pretty complicated question. If you think about something like a pencil, maybe people buy the same number of pencils every year, except for when it gets back to school and then there's a spike. But there are products that the company might not know how many will be purchased on any given day. Think about a new product that's, an innovative technology. They might not know if a lot of people are going to buy it or only a few people are going to buy it. But they're going to have to make the decision of how many to purchase to put into their distribution centers and then which distribution centers to store them at. So it's this big network optimization problem. And ultimately, if they make the wrong guess, they're just going to have to spend more, right? They are going to have to ship it from California, and they might have to fly that product. And so it's understanding customer needs and demand and transportation modes like air versus rail versus putting it on a UPS truck versus utilizing things like Uber drivers and drones, right? If you guys have seen articles about how companies are actually utilizing these new innovative transportation methodologies to ship regular products. So, it's a very innovative space. Don't think about it just being putting on a UPS truck and getting it to your door. There's all these new ways that are constantly evolving. And behind all of this are different types of mathematical models that an industrial engineer would use to solve the problem. But I always like to don't focus on the math, focus on how cool the problem will be, and you'll learn the techniques to get there. So that's going to be the point of my talk. So in terms of manufacturing processes, this is an area where a lot of students often wonder, what's the difference between maybe a mechanical engineer and an industrial engineer in the manufacturing space in particular. And the big distinction between the two is that we are more on that process focus versus the mechanical engineer might be more involved with aspects of design. We do take courses in design, again, to be able to work with the different disciplines and know enough about each of them so that we can work well together. But we're really looking at the process. So what's the best type of equipment? Should this be an automated process, a manual process? How should the production process be scheduled? How do we monitor things like quality? That's really important, especially now, consumers for most things, we have a lot of choices. So given that a company can have a competitive edge due to their quality, which might have to deal with how they're manufacturing the product or what kind of material is selected, those are roles that an industrial engineer could have in that manufacturing space. Also, going back to the quality idea, there's a lot of data that's generated by things like they're measuring different aspects of the product, or they might be gathering a lot of data from customer calls. Industrial engineers could look at that information, not just analyze what that means, but then drive home the resolution and the changes to the process or the product or the manufacturing. It might be something with the supply chain. Again, all these ideas are really interconnected. It might be that the packaging causes the product to be damaged in a lot of the shipments that are sent out. The IE would be an integral person in the problem, troubleshooting and problem solving. And going back to what the last speaker was mentioning about critical thinking and communication, I think he was completely spot on. Those are really, really critical aspects of what a successful engineer looks like today. You'll get the technical background, but being a critical and creative thinker, that doesn't actually just come as naturally as you might think, especially if you're used to more 2 + 2 = 4. I mean, is that really thinking critically? You're just kind of going through the motions. We really want to teach you to think beyond maybe what the traditional way of thinking might be. And just to touch briefly upon this area of ergonomics and usability, actually he mentioned usability from the perspective of maybe interacting with a software package. For an industrial engineer, this is a niche area, and really the only area that we consider would require an advanced degree in all likelihood to do this as your full-time job. So in terms of ergonomics, let's say you're designing a manufacturing process, ergonomics is looking at how the person interacts with their environment and making sure they can do that in a safe way. Let's say a UPS worker that has to load packages onto the truck. They should not be, bending to the floor and lifting a 60-pound package. There should be a system that would help them, whether it's a physical system like an automated assisted lift technology, or just that they're doing things off the ground on a table, whatever it might be, something that you would design in terms of the process to make it safe. But then also looking at not just the physical system, but the cognitive system. So think about a pilot. When a pilot is flying a plane, there's a lot of dials and information and data that they're constantly having to absorb. That's really hard. And if you're looking at redesigning the next generation of planes, you might be looking at different technologies to simplify that display or cause them not to have to look down. So there are technologies called heads-up displays, where by looking just at the windshield, a lot of that data could be presented there. But we don't know what the impact might be on that decision maker when you redesign something like a very complex cockpit. So we have in our labs, which we're still located on main campus, we have different flight simulators and driving simulators where they could test these new environments and actually collect data on things like response time. Wouldn't you want to know if your redesign caused a pilot to be able to react more or less slowly to some sort of emergency situation? That's kind of critical, and you don't want to wait till you build the plane and say, I hope that works out well. So we can do things in a simulated environment, collect that data and analyze them with just our industrial engineering methods to make sure that what's being designed from an ergonomics or usability perspective is actually improving the experience. And so, I'll just play this little clip while it's going. Another area that is really the backbone of a lot of what we do is actually this area of analytics. So analytics is really a broad term for using different mathematical methods and applying them to data from our perspective to aid decision making. We don't want to just generate charts and graphs because you can. We want to know that what we're developing actually is going to help you make a better decision, whether it's how many products do I stock, or hey, we need to stop the manufacturing line because there's a quality issue. We're using these sorts of tools. And so in that little graphic was actually an output from a simulation model. And a simulation model is just one of the operations research techniques, one of the mathematical modeling techniques that we utilize to mimic and represent any sort of system. It could be that grocery line, it could be a healthcare clinic, it could be a manufacturing process. But in that simulated environment, what we're able to do is make changes that aren't affecting the real world, but they might be something we might consider doing, like hiring more grocery clerks, or something more expensive, like opening up an additional operating room on Saturdays in the ER. But in that environment, you can generate a lot of data, which is what you were seeing. That was an output from a specific simulation model. And then looking at that data, we can help to make those decisions. Let's hire 2 nurses on Saturdays from 8 to noon because we do see there's a surge in patients that come to the ER. And the most cost-effective and best way to deal with that is to hire the nurses not to open up the operating room. So we can play around with those different scenarios without impacting the real system, but ultimately help that aid our decision making. So this is a big emphasis area in cross-cutting across manufacturing, supply chain, healthcare, because this is really the backbone of mathematics that will drive a lot of the decisions and models that we develop as an industrial engineer. Big data is obviously a huge trending topic, and it's completely aligned with what we're doing with what computer science is doing, and probably some other things too. So where will you work as an industrial engineer? And I'm going to show you a quick video that's put on by our professional society. As you can imagine, really this idea that we deal with processes and systems means that we work everywhere. We have students that have worked at Disney World. So you can think of Disney World as a huge system. There's lines, you're being processed. We boil everything down to the same thing. That's kind of the beauty of being an industrial engineer. A manufacturing process where products are going down the line, being built and spit out at the other end is really the same thing as you waiting in line for the Peter Pan ride, and then you have the ride experience, and then you come out at the other end, you know, hopefully a happy customer. But Disney, they charge you a lot of money to go there, right? They can't have disappointed customers, and so that's why they have these teams of IEs looking at innovative ways to make the lines go faster, for you also to be more entertained during that wait time experience. That kind of goes back to kind of that cognitive perspective. And then you can see obviously a lot of the big manufacturers. Duke Hospital is actually one of the health systems that's really embraced bringing industrial engineers into the healthcare space. They have an entire department of industrial engineering type folks looking at things like patient wait times, overtime, quality of services that are delivered to you as a patient. That's obviously a really, really important part of healthcare, especially now. And they've been able to identify that we're the types of engineers that have already been doing that sort of work for a long, long time in many other industries, and that we could make that impact in healthcare. So that's a new, kind of newer, exciting area that's grown. So the video I'm going to play is put on by the Institute of Industrial Engineers. That's the Professional Society of Industrial Engineering. That's a great website to go check out if you're interested in more information, as well as our departmental website. But I think this will really give you some great examples of what industrial engineers do related to the topics that I already talked to you about, but with real people that are doing those jobs right now.
And testing an international laboratory in space.
My work helps patients at our hospitals get better care. Every day I am improving how we make some of America's favorite treats.
Our motto is we never forget who we're working for, and who we work for is the U.S. military.
Within 10 years, every hospital in the nation will have an industrial engineer associated with their team.
I help create magical moments at one of the world's most famous places.
Industrial engineers are problem solvers. People who find that it's creative and fun to make things work better.
The International Space Station travels around the Earth at 17,500 miles per hour. That's 16 times a day. 6 astronauts from different countries live there, performing experiments that will benefit life on Earth. I lead a team of people that assembles and checks out the hardware that will be flown to space, which will then be used by our scientists. This module just came back from space, and actually we opened up the hatch yesterday. As an industrial engineer, I'm contributing to one of the greatest technological achievements in human history.
I like my job because it's different every day. In this plant, we make about 1 million pounds of chocolate every day. Even in a company as successful as Hershey, industrial engineers can always help improve what we do. We ended up collecting rows of bars and looking at the almonds percentage by bar. Our Hershey bars with almonds did not always have a consistent number of almonds. I led a team to make design changes to the equipment, so now the bars have a more consistent number of almonds. Now we are producing better quality bars, our customers are happy, and the company is saving money.
Lockheed Martin is the #1 defense contractor for the United States government. I'm responsible for the operations element of the missile and fire control business. The approach we're going to take to build and test things, the manpower we're going to need, the technology support, the whole backbone of what we do is all around culture, what I'll call culture of being an IE. When my customer comes back and tells me the products I made saved their lives, there's no more customer satisfaction better than that.
Industrial engineers are the kind of people that find the shortest, quickest, cheapest, best way to do something and think it's fun to solve that puzzle.
We try to strive for delivering excellence and quality in all we do.
Not only do they have good technical skills, they're good in math and science and computers, but they also have good people skills. They learn how businesses work. They learn how the world works.
They look at the whole picture. and they try to understand where it all fits.
Starting salaries now are in the $55,000 to $65,000 range. Industrial engineers are in more demand today than they ever have been.
Because there's so many things you can do with IE, I don't really feel worried about my next step in my career.
Hospitals today are busier than ever, so it's really important that each patient gets fast and quality care. As an industrial engineer, I work directly with doctors and nurses. And you find that having a standard process with a huddle has really improved your metrics as opposed to what you were doing before. We develop ideas to make the hospital run more efficiently and make procedures like lab testing more accurate. Seeing patients get better and seeing them happy about their care, it really means a lot, and it makes you want to come to work every day.
I remember coming to the theme parks as a kid. I wanted to experience everything. Now my job at Disney is to make sure our parks and resorts are fun and efficient, so our guests get the full experience. I observe how our attractions are operating and analyze data to make improvements. New changes to Space Mountain are making wait times shorter and more entertaining. Think about the number of people that come through our turnstiles, and getting the opportunity to say, yep, I had a hand in improving their experience is definitely rewarding.
You guys get the gist that it's a very diverse field with a lot of different application areas, but that our emphasis is on that improvement side of what a process or system might be defined to be. So I'm happy to take, I think there's just a couple minutes. If you guys have any questions, I'm happy to answer them. Yes.
Can you talk about your experiences in industry and academia? You said that once you graduated, you worked in the industry.
Right. Yeah, very different roles, I would say. So the job at Dell was great because it was very dynamic. If you're working for a high-tech company, obviously, and you're turning out new products every 9 months, there are just a lot of moving parts all the time to what your job is. And you're usually working on multiple products at the same time. And I really liked the global travel aspect of it, because a lot of our development, was done with these manufacturing facilities overseas, suppliers overseas. And so it is this complex systems problem. But being able to get experience going abroad and managing products at that level, at 22 years old, I think was really impacts what I do today. And not having had that experience would make me a very different teacher. So one thing that I've tried to continue to do is to do consulting, because I think as the previous speaker was talking about, a lot of times it is a challenge for us to teach in whatever the latest thing is that's going on in industry, because it's moving so quickly and we're not embedded in that world. But I think that by continuing to keep a pulse and partner with companies, whether you're partnering with them to bring projects to your classroom or you're doing consulting work, it really helps to inform how you teach. So that's something I'm really passionate about in terms of on the faculty end and being a professor, is making sure that my class is applicable to the real world. If it's not, it's hard for me to be interested at that point in time, frankly, because I'm really motivated by developing student skills that I know will make them successful out there in the crazy real world, which is very different than any sort of clean equation that has a solution. So I'm lucky enough that I teach a project-based class where all of our projects are industry sponsored, and then we are able to kind of go through an entire project from start to finish with a company. And the students really get a lot out of that experience because they see how complex a real problem is, and that data might not actually exist. In all problems that you'll have had, definitely before you get to college and even a lot in college, the data's given to you. And then you realize that you need to kind of take a step back from that and be able to solve problems when you don't have all the information. So anyways, two very different roles, but something I've really tried to do is bring in a lot of that industry side into my classroom specifically. Yes?
If I was an industrial engineer, you have to go out and figure out ways to get the data.
Definitely. A big part of the challenge that we have is, how do we get that information? Is it being captured already by some computerized system? And you'd be amazed, even large tech companies, I won't name names, that we work with in our project class that you would assume must have all the data in the world, because that's basically the business they're in, don't have the data. And so something as an industrial engineer that you need to do is not only, you might need to be collecting the data yourself, you might be helping to develop the database that will start capturing this information, but you need to be able to also make the business case that collecting this data is going to give you value. I think that's a challenge today, is that we can collect, in a lot of circumstances, data can be collected very easily, but if you're really not going to do something with that information and help it to feed into a model that's going to help you make a particular decision, then what's the point of gathering that information? And usually gathering it isn't free. It's either going to be resources or a new database developed, that you need to have a team that's going to be assigned to that. So as an IE, my job would be, why do we need this information? Let me show you how bad our decisions are today and where they could be in the future if we had this information and we were able to do the analysis that we should do. That's a good question. All right, I think we are out of time. Thank you all very much.